The overall goal of this method is to assess the performance of the achromatic doublet on a glass Fresnel lens as new optics for concentrating photovoltaic systems.
The method allows to determine both the transmission efficiency of the optics and its concentration ability by measuring the size of the spot cast by the lens. The evaluation of the optics is carried out by measuring how well it concentrates light on multi-junction solar cells. These devices convert into electricity irradiance over a wide spectral bandwidth.
In concentrator photovoltaics, the chromatic aberration reduces the maximum attainable concentration when using refractive primary element. This limitation is avoided by using the achromatic doublet on glass Fresnel lens we have designed. The design includes two different materials, a plastic and an elastomer, having different dispersion, that is, the refractive index variation as a function of the wavelength. The inexpensive manufacturing process includes the lamination of both materials on a glass substrate, in order to obtain a parquet of lenses. For every measurement, a silicon on glass Fresnel lens is used as benchmark.
The solar simulator for concentrator solar cells, Helios 3030 from Solar Added Value, has been used to perform the measurements. This equipment is able to measure MJ solar cell under concentrated light up 1000 suns with controlled spectrum. Place the top, middle, and bottom reference isotypes inside the solar simulator along with the solar cell to be measured. Place them as close together as possible in order to reduce errors due to non-uniform illumination at the measuring plane. Next, adjust the flash lamp.